Okay, we're finally going to get through this section 2.1. Now, most of your sections will not require near about this many videos. It's just that this section 2.1 is such an important topic, and it's a very fundamental thing that we use in a lot of other areas in algebra, some of the similar concepts. So that's why we kind of creep through this section. It's also why you have 3 full sections of homework on 2.1 is because of the importance of this topic that we're covering. So we're going to close out this topic, and now what I want to do is I want to talk about what do we do with an equation that contains decimals in it. Now once again, remember there are multiple ways to do this. There's not just one way to do it. And so what I'm going to do is I'm going to show you how to deal with it so that you can get rid of all of the decimals right out of the gate. Now, one of the options is you could use your calculator and work the entire problem with the decimals. One of the reasons we don't do that in this course is because they want all of your answers in exact form, and which means generally they want you to write your answer as whole numbers or fractions, but don't write any of the answers as decimals. So that's one of the reasons I teach it this way. So I want to show you how do we deal with decimals when we have decimals. And when I say decimals, understand every number has a decimal. So if I say the number 23, 23 is a decimal. It's just the decimal is at the end of the number. Just like every number is a fraction. If I say 8, is 8 a fraction? Yes, 8 over 1. Now, do I call it a fraction? No, not typically. But it is a fraction. It's what's called a rational number. So the number 23 it does have a decimal in it. It's just understood at the end. So what I'm talking about is equations where you have decimals in the problem where they're not at the end of all the numbers. And so how do we deal with that? Well, before I do that, I want to remind you of a couple of things. First of all, remember that 0.7, and by the way, the 0 is not necessary here, but we usually put it just so that you can see that that decimal is there. So, but if you do put a number in front of that decimal, it must be a 0. So 0.7 and 0.7 is mathematically the same thing. But we will typically write it this way. All right, remember this 0.7 is the same thing as 7 over 10. Now, if I have 0.07, remember that is 7 100ths. If I have 0.007, sorry about that, 0.007, that's 7 1,000ths. Do one more. So if I have 0.013, this 3 is in the tenths, hundredths, thousandths place. So this would be 13 1,000ths. So what is a decimal? It's just simply a fraction. So a decimal that is to the tenths place is a fraction of a denominator 10. A decimal where the last place is in the hundredths place, that's equivalent to a fraction with a denominator of 100. So if a problem has fractions in it, that just simply means the denominators are either 10 or 100 or 1,000. Now, how did we get rid of fractions? You found the least common denominator, like 2 and 3, which is 6. Well, if a problem has decimals in it, those are fractions, but the denominators are either 10 or 100 or 1,000, depending on how many places they're to. So here's what we will do. If an equation has a fraction where you have decimals that are to the tenths spot, what we will do is multiply through by 10. Now, what does multiplying through by 10 do? Well, let me just show you this. So if I have 0.6 and I multiply that by 10, that just gives you 6. Here's the reason. 0.6 is 6 tenths. times 10, which is just 6. So if we need that decimal to be moved one place to get it to the end, we're going to multiply by 10. Now, what do you think we would multiply through by if we need that decimal to be moved two places? That's right, we multiply through by 100. If we need that decimal to be moved three places, we would multiply through by 1,000. Now, what if some of the decimals are to different places? What if some of the decimals is to the 10th spot? What if some of them is to the 100th spot? Remember, you have to multiply by the same number. So if some of them is to the 10th spot and some of them is to the 100th spot, you multiply by the bigger of those numbers, which is 100. So, in short, how do we solve an equation with decimals? You multiply by either 10 or 100 or 1,000, whatever is big enough to get all of your decimals to the end. Let me show you some examples. So let's suppose I have 1.2 x minus 2.3 equals 0.5x plus 1.5. Notice two things. Every one of these problems has a decimal. Every one of these terms has a decimal that's not at the end. Now, they don't all have to have decimals that's not at the end. But every one of these decimals is to the 10th spot. So what I'm going to do is I'm going to multiply through by 10 to get rid of the fractions. Now remember, whenever we multiply through by 10, we have to multiply every term on both sides. So I'm going to do 10, 10, 10, and 10. Now, what does multiplying by 10 do? It moves the decimal a 10th spot. So this would be 12x, so it moves it one spot. And if you don't see that, take your calculator and punch in 1.2 times 10. It'll give you 12x minus 23 equals now 5x plus 15. So now I have an equation that has no decimals in it. There's decimals there, but they're all at the ends of the numbers. So now we're back to the two-step process. 12x minus 5x equals 15 plus 23. So this would be 7x equals 38. Then divide by 7 to get 38 over 7. Now, I haven't mentioned this for quite some time, but let me say it again here. If you took 38 over 7 and you put it right here, and you took 1.2 times 38 over 7 minus 2.3, then you took 38 over 7 and put it right here and multiplied it by 0.05 and then added 1.5, those two answers on both sides would be equal to each other. It would give you the same number on both sides. And this is the only number that you could put in for x that would make that happen. That's why we call 38 over 7 the solution to the equation. All right, let's do another one. Let's do 0.1x minus 2 equals 0.03 plus 1.2x. Now let me say again, this is not the only way to work these problems. But I don't like teaching problems 4 or 5 different paths to work that one problem because it ends up confusing students more than anything. So I like the same approach to every single problem, even though it may not necessarily be the shortest. It's the same approach. All right, so I've got a decimal to the 10th spot. That decimal's at the end. I have a decimal that's to the 100th spot and a decimal that's to the 10th spot. So 10th, 100, tenths. Well, remember, you have to multiply through by the same number. So if you multiply through by 10, that won't take care of this because it'll only move the decimal to right here. So I'm going to multiply through by 100. But when you multiply through by 100, you must multiply all 4 terms by 100. Every term on both sides. So 100, 100, 100, 100. Now, what does multiplying by 100 do to your decimal? It moves it 2 places. So when you take 0.1 and multiply by 100, it doesn't move it behind the 1. It has to add 1 more place. So this now becomes 10x. If you don't see that, punch it in with your calculator. Minus, then this is 200 equals, and then 100 times 0.03 moves it to the end because that's 2 places. But then when you get right here, it's got to move it 2 places. If you get it, put it behind the 2, that's only 1 place. So you have to add a 0 there as well. So that's 120x. Now we're back to the same 2-step process. And then we get negative 110x equals 203. Divide both sides by negative 110. That cancels, leaves 1x. And a negative into a positive is a negative. We typically just put it out front instead of leaving it in the bottom. And 203 over 110 does not reduce. Okay, let's do one more example to finally close this section out. I know you will be glad that we're finished with this section. So let's look at this one. 0.13 minus 0.02 times 2x minus 3 equals 0.05x plus 0.19. All right. The first thing that I notice here in this problem is that all of my decimals are to the 100ths place. So that makes it easy. So I'm going to multiply through by 100. I mentioned this a while ago, but let me mention it again. This is 1 term. So I'll put a 100 here. This is 1 term. I will put a 100 right here. This right here is 1 term. So I will put a 100 there. This is not 2 terms. It is 1 term because of the multiplication. Now you say, could we distribute first? You could, but I'm not. I'm going to get rid of the decimal first. But just remember that this is 1 term, not 2. All right, so when I do that then, I will have a 100 here. 100 there. Don't put it in both places. A 100 here and a 100 there. Now, when I do that, 0.13, when you multiply that by 100, this becomes 13. Minus 100 times 0.02, this becomes 2. But after you do that, you have to distribute that through. I'm not going to do that in this step. I will do it in the next step. If you do go ahead and distribute the 2, don't forget that it's negative. That's a real easy place to make a careless mistake. I'll do it in the next step. Equals 0.05 times 100 just becomes 5x. And 0.19 times 100 becomes just 19. Now, if you'll look at this problem looks just like the ones we've been doing earlier in section 2.1. I want to do as much as I can on both sides. So I want to distribute here to get rid of the parentheses. So this would be 13 minus 4x plus 6. Negative 2 times negative 3 is plus 6 equals 5x plus 19. Can't do anything to the right side. The left side I can still clean up a little bit. Bring down the negative 4x. I can add these two terms together. 13 plus 6 is 19. Now, I want to get the x's on one side, I want to get the numbers on the other. So when I do, get this, if you do it in one step, so this would give me negative 9x equals 0. Now, if you're not careful right here, you'll say, oh, okay, this is the one that's either no solution or all real numbers. No, it's not. How do we get rid of the number in front of x? By dividing. So to get rid of this coefficient, you divide by negative 9. Not negative 9x, just negative 9. The negative 9's cancel and leaves me with x equals 0. Now, let me remind you of the no solution in all real numbers to close out this section. So, what would have had to have happened if this answer had been one that was no solution? Remember, what happens in that case is, if it had been 0x equal to some number, that's no solution. But if it's 0x equals 0, that's all real numbers. So if the variables goes to 0, it's either no solution or all real numbers. So if it's 0x equal 8, 0x equal negative 3, or whatever, any other number other than 0, it's no solution. But if it's 0x equals 0, that's all real numbers, always. That did not happen in this problem because the number in front of x did not go to 0. And I showed you why, when we did these, why this one was no solution and this one was all real numbers. Okay, so I hope that these videos have helped. This is exactly the way I would teach it in my class if you were here. So I'm not leaving out anything. The only difference is you're not able to stop and just ask questions if you have any questions on anything. But you can certainly contact me. You have my email address, and you also have my cell number if there's anything you don't understand. So this completes all of section 2.1. So at this point, we have finished all of section 1.3, all of section 1.4, 2.1 in your homework, part A, 2.1 in your homework, part B, and then 2.1 in your homework, just 2.1. So there's 3 sections of homework in MyLabs Plus in section 2.1. What we will do now is we will go to the very next section of chapter 2 that's in your homework, and that will be section 2.2, and deal with some what we call application problems. So that concludes this video. I will start the next 20-minute video shortly. Thank you.